Hello and welcome to Sean White's Solar and Energy Storage Podcast. This podcast we have Geoff Ferrell, and Geoff Ferrell is from Sonnen. Hey Geoff, welcome to the podcast.
Hey, thanks for having me. Good morning, and happy to be here.
Yeah, thanks so much. And one more thing too is if anybody out there wants to learn more about solar and storage, you can go to solarsean.com and find out everything you want to know, or you can go to the Sonnen website, and that is...
Yeah, Sonnen is SONNEN USA.com.
Great. And let's have you introduce yourself, because you're probably better at that than I am. You could kind of give your background and things like that.
Absolutely, yeah. Again, happy to be here. Thanks for having us, Sean. My name is Geoff Ferrell. I am Senior Vice President of our virtual power plant and project business for the U.S. company, Sonnen Inc., as well as global lead for our commercial industrial project business. So a couple hats that I wear, leading both our U.S. business as well as some global aspects, which is a whole lot of fun. I've been with Sonnen USA for about 3.5 years now, a little over 3.5 years. I came from the built environment. So prior to this, I was actually a Sonnen customer. I worked as a chief technology officer for a small home builder in Arizona called Mandalay Homes. We were building highly energy efficient, healthy, durable, sustainable housing that incorporated solar and Sonnen energy storage in every home we built. So we gave Sonnen one of the early specifications for batteries in a master plan community as part of a overall energy efficiency initiative in those homes, in partnership with a rate structure that Arizona Public Service was offering. And then about 3.5 years ago, I had the opportunity to take that show on the road, I guess you could say, spread that word a little bit wider by joining the Sonnen team, at the time form the project business to complement our healthy channel business and really help develop that whole project. I've got a community, I've got a initiative, utility comes and says, I've got an initiative that we need to do this, that, or the other thing. I have no idea where to start. And that really was what my team was designed to do, was to be able to come in and say, well, we can help you start somewhere. Let's have a conversation and see where you'd like to go, and then bring the resources to help them take a project from completely lost ideation all the way through to operation.
That's awesome. And just a little background, too, for the people out there, is that I already had a Sonnen podcast with Greg Smith, who used to work there. He's also a friend of mine. He also wrote a solar book. And that was 3 years ago. I'm going to put a link to that in the show notes. And Greg is a good guy. And we actually went on for a long time just because he's a friend of mine, and we were just kind of shooting it. And I actually broke it into 4 different podcasts, which is not something that I typically do, but we were just having so much fun, thought I would let everybody get in on that. So just to kind of start off with, I noticed that you pronounce it Sonnen, and so it sort of sounds like zone, like the end zone or something like that, and I guess that might be the German pronunciation?
Yeah. We had a spirited debate a couple months ago about really what the pronunciation's supposed to be. So I'm trying to adapt a little bit. It's still a little weird for me. So Sonnen is totally acceptable in the US. It's got a little more of a Z to it in the German. But either way, it doesn't translate exactly, but it is kind of the plural of sons in German.
Oh, okay. I like having multiple sons in case one goes out. That's always a good thing to have. That's good that you have that going on. Yep. And then I also noticed that you always make it lowercase for the S.
Yeah, I guess some marketing person somewhere thought that was fancy. It's fun.
Yeah, that's so fancy. I'm so impressed. I'm going to start doing that with my name. You can call me lowercase Sean.
It's definitely a learning experience when you're writing documents, especially when they start with the word Sonnen, because you have to go back and break the auto capitalize every time you do it.
Well, that's pretty neat. Yeah, and it does sound sort of like sun. I always thought that was in there.
Yeah.
So I kind of have a lot of different topics we can talk about, and we can just see where that takes us. And so one of the things is that I know that what you're kind of famous for is the virtual power plant, the VPP, and I think that's super, super exciting. And I know that when I was talking to Greg 3 years ago, he was talking about doing it, I think it was in Utah, the Soleil Lofts, something like that. And is that still happening? Are you going a lot further than that since then? Because it's been a while. And then what's going on around the world with the virtual power plants?
Yeah. Greg teed us up well. So thanks, Greg, if you're listening to this. Appreciate you. Absolutely. Yes. So we like to think ourselves famous for originating the virtual power plant as well. It has been a fixture of the Sonnen brand for, gosh, over 8 years now. Really started in Germany, where the energy market was a little more advanced than we see here in the US. Definitely the European German market is leading the way with renewable penetration, how that's handled on the grid, and really kind of optimizing multiple generation sources and optimizing that to help stabilize utility bills, help stabilize the grid from variable, intermittent, silly things that happen when we do these really great things like solar and wind and biogas. And just a great model that works really well for us in Germany. In 2017, brought that over to the US. The US company has been around since 2016, but started bringing the virtual power plant to the US in 2017. And that all really kind of took off with Soleil Lofts. So Soleil Lofts is a 600 unit, 100% electric multifamily community in Herriman, Utah, south of Salt Lake City, part of the Rocky Mountain Power grid. And what that project was or is the beginning of what is now known as WattSmart. So Rocky Mountain Power joins me, I think, in the dislike of the word pilot. Pilot kind of, it's got a little bit of a connotation, in the industry these days. Rocky Mountain Power didn't exactly want to do a pilot. And they said, look, if we're going to test this, let's test it in such a way that we can see some real results, so we can see some real effectiveness out of a swarm of solar, a swarm of batteries being intelligently controlled in a virtual power plant. So I said, let's do Soleil Lofts, 600 units. It is 625 batteries in total, providing a little over 12 megawatts of dispatchable power and harnessing a bunch of solar on that site. So really smartening up that solar, providing Rocky Mountain Power with direct access to those resources so they can choose what they want to do with that solar, choose what they want to do with that stored energy, including net injections to help with voltage and frequency regulation, all kinds of products that they're doing with that. But Soleil Lofts was really the beginning of it. We are done building that project. It is fully operationalized, being operated and steered every day of the week. Like I alluded to a moment ago, that was the start of what is now WattSmart. So they have a territory-wide program called WattSmart. It is open to every customer in their territory that wants to install a battery and then connect that battery to Rocky Mountain Power's virtual power plant software to be steered, controlled, and to lend that energy to the stabilization and harmonization of their electrical grid.
That's pretty awesome. It must take a lot of smart attorneys and engineers to figure out how to draw up a contract for a virtual power plant and how to know when to push the electrons this way and that way and make it last for a long time. How does that work?
So yeah, certainly regulation, regulation is first, both, at the FERC level, as well as being aligned with state regulators, the State Utility Commission, and the goals of a particular utility. So, speaking of Rocky Mountain Power specifically, they have amongst the country's most aggressive goals, really beautiful goals, to decarbonize their grid and decarbonize their profile. They're doing a phenomenal job. I don't know the exact number, so I won't spit out a number, but they have a really decent percentage of renewable-based energy on the grid already. A lot of that's coming from hydro, grid-tied solar, grid-tied wind, doing a really, really great job with that. And what they're looking for was a way to involve their customers in that future, to say, look, we're doing really great things for you. Utonians, I don't know if Utonian is the right word, but I'll say Utonians, a little bit of Idaho, Wyoming, some other territories that Rocky Mountain Power's in.
Yeah, I mean like Utah and things like that? Is that what you mean?
Yeah, exactly. Yeah.
Okay.
Utah natives. So
okay.
I'm in Southern California. We're Californians, so maybe I made up.
Okay. All right.
I don't know. Yeah. Maybe we'll see.
And I actually happen to be in the Rocky Mountains right now at the ESS Solar Conference, American Solar Energy Society. So shout out to them.
Absolutely beautiful part of the country. I wish I was there at the conference myself. So yeah.
Next year,
absolutely.
Well, next year it's going to be in DC, I guess. So.
Oh, fantastic. Okay. Yeah, if it's a little earlier in the year, we can catch the cherry blossoms, but, beautiful town.
Yeah, actually, I think it might be. So, I don't know. We'll see.
Okay. I'll check out the website. But Rocky Mountain Power was really looking for opportunities to involve their ratepayers in solutions for the future, to help keep the grid reliable, to embrace renewable energy, and to keep rates low, of course. Those are their big things that they've really communicated to us kind of as a partner and provider of the virtual power plant software layer. And of course, some hardware. They embrace other hardware as well, but it's our software layer that's really running their system, which they call the DBGMS, Delta Bravo Gamma Mike Sierra, the Distributed Grid Battery Management System, because it's a utility. They love their big acronyms. So that's what they call it, the DBGMS.
DBGMS.
DBGMS, a new acronym for us, Sean, as if we don't have enough in this industry already, right?
Well, at least one that's that long, somebody else isn't using it for something else, probably.
Exactly. Good point. But you're right. To your earlier question, the DBGMS, really, the goal of that system was to say we want really robust control, swarm control of energy storage systems specifically. So that system does not handle their thermostat program. It does not handle their other programs like pool pumps or irrigation pumps. It is specific for energy storage systems behind the meter. That's both residential and commercial. So they could do these really complex things around scheduling, around receiving signals from their planning department, and to be able to dispatch energy storage systems directly to use them like they would a peaking plant or, another large resource that's a spin or non-spinning type resource that they would call on that's traditionally fossil fuel based.
Yeah, last night at the conference, I heard a term that I liked. It was by a guy, Peter Green, who's a genius over at NREL, and he called it an inverter-based grid, I think is a term that he used. And so we're seeing all these spinning things kind of spinning down a little bit, and then we're getting all the inverters out there using electronics to make the grid, and that's just going to be pretty much required. And there's just a lot of evolution and adaptation, and I think that the virtual power plant is something in its early stages, and it's kind of even hard to define right now. Like, it includes batteries, we know that. Does it include load control? Does it include bidirectional electric vehicles, PV systems? Probably eventually all that stuff, and then we have that real fancy acronym of AI that I think, going to be in there at least. And then how does it work, like based on, from the utilities point of view, from the person that's sort of like the operator of it, like Sonnen, and then also from the point of view from the customer, like what happens is if it's a heat wave or something like that and the grid's having trouble, do you get a check in the mail?
Yeah.
And I think that's evolving, how that's going, but you would probably know more about that than I would because you get to see it from your perspective. And I remember too, when I was talking to Greg, he was even saying that the Sonnen virtual power plant could also work with other brands of inverters, like all your competitors.
Absolutely. Yeah. So a lot to unpack there. Yeah. Try to tackle all that. Yeah. Greg, another great point from Greg. I think the reality, from my perspective, the reality of it is if we want to embrace real energy transition, if we're serious about saying solar is part of our future, wind is part of our future, hydro is part of our future, these renewable-based generation sources are part of our future, and we're serious about decarbonizing energy generation in general, it's an all boats rise kind of proposition. There's no single manufacturer on the planet that has the resources or money to make enough inverters or batteries fast enough for us to achieve the goals that we want to achieve as a society. So it really does have to be a solution where you say, if you've got great technology, if you've got a great inverter that reacts quickly, that's reliable, dependable, robust, and that is coupled with energy, with battery, battery modules that are safe, reliable, robust, durable, we've really got something there. And then to be able to swarm control multiple of those. I think one of the obstacles we run into as an industry is that no utility or grid operator or, the CAISO or ERCOT, I think it's unreasonable to say that they have the resources or the impetus to want to control 50 different VPP platforms. It's just not going to work. That adds a level of burden that would drive energy costs up and add complexity up to the level that it just isn't feasible. So we as an industry need to continue to work together to figure out, how do we really want to go to market? Who's got a solution that really works well for the grid operators, for the markets and the ISOs within the United States that we can come together and operate really great hardware, operate really great software platforms, and derive real solutions from it, whether that's harnessing grid power or local rooftop solar or wind or whatever it may be.
Yeah, one way that I kind of look at it too is it just kind of seems natural that, I mean, if you look at it, it's like one person with a 10 kilowatt hour battery on their house. They're not going to go negotiate with the ISO and say, okay, I'm going to send you some power now at exactly this second and do it within a millisecond and coordinate it all themselves. That can't happen. But if you coordinate together thousands of batteries, and then it's sort of like the virtual power plant provider, I guess you could call it, would be the one that would negotiate with the grid on your behalf in order to sell to the grid. That just kind of seems like one way of looking at it. Does that sound right?
That's exactly right. Yeah. And you kind of teased it a little bit earlier so skillfully. Rocky Mountain Power and the WattSmart program, that's one way to go about it. They are a vertically integrated model. Rocky Mountain Power, by rule, owns generation, owns transmission, owns distribution, owns the customer. It's a great model for that part of the country. The way that they would implement a virtual power plant, incentivize it, rebate it, and involve their customers is a very structured way that works for them. And we're very happy to be partnered with them to provide that. Then you go to other parts of the country, like California, for example, where we have a semi-deregulated market for the vast majority of the state. Anywhere that you have PG&E, SCE, or SDG&E as your utility, it's basically deregulated, and you can operate at the CAISO level and do exactly like you said, Sean, where you say, I'd like to create for you, Mr. and Mrs. Homeowner, a really compelling offer that you want to put solar plus battery in your home. You want to join this program. And when you join this program, what we're doing is we're going to set aside a certain reservation of your battery. We're going to give you some controls on your battery. So if something's really going awry, or, you think that there's a really bad storm rolling in, not that we get bad weather in California or Southern California anyways, but you feel like there's bad weather, you still have control. But what we'd like to do those 360 days of the year where everything's perfect and the sun's shining and you're going to work, going to school, you don't have a care in the world, we'd like to monetize your battery on your behalf. We'd like to help you optimize savings on your utility bill, and we'd like to help you earn money by bidding that battery into the market. And you don't even know what that means. You don't even know what that means. That's crazy. I'm not going to go into how we bid your battery into the market. You don't know what the market is. What I'm trying to tell you is I basically can cut you a check a couple times a year, quarterly, whatever it may be, and for doing things that your home's already doing. But what we can do is we can monetize your battery further, help you really buy down that ROI, make a lot of sense for solar plus battery, or even battery alone under some of the new rules in the Inflation Reduction Act. And that really is what we have today. So Sonnen has launched Sonnen Connect. We have Sonnen Connect in California today, coming to other parts of the country very soon, where we are actively enrolling hundreds of customers a month into that virtual power plant, where we're aggregating their individual loads, bidding them into the CAISO market, as well as doing some professional management of their system and helping them save as much money as we possibly can, using AI, using some machine learning, using some algorithms to optimize the way their home charges and discharges from local solar and grid, and then bidding their battery into the market when it's advantageous for them.
Yeah, I was just looking through some articles too today, and one of the things that I noticed is it looked like there was something about electric vehicles, like bidirectional electric vehicles that would work with Sonnen. And I think that pretty much that most of the energy storage in the world, probably by far, is in cars. And eventually, we're just going to have bidirectional electric vehicles because it's going to have to be that way for the grid to work. And people are going to make money from their cars and just when they're parked. I mean, it's just going to be a win-win for everyone. It's going to make the grid work. It's going to make this whole thing work. And so, of course, there's not a Sonnen car out there, and I don't expect you guys are probably working on one, but maybe, who knows? But that also kind of brings up the software versus the hardware thing. So, like, I'm working on a computer. I guess I'll just mention the brand name. It's a Mac, and it does have a hardware and a software component, and it's the same company. And so for you, I guess you're going to be working with different types of hardware with your software, putting that onto and off of the grid. Does that sound correct? Do you want to comment on that?
Yeah, it's fair. Couldn't agree with you more, Sean. The grid of the future does involve vehicles in a bidirectional communication for sure. Whether that's bidirectional energy movements, I think we're in some of the early days of that. I think that's to be determined. I think there's a lot of question around the how a car battery's longevity is affected when you use it in a household versus using it as a car. They're two very different use cases. But yeah, going to your comment about the press article you saw, in Germany, we do have our Sonnen charger in the German region of the country. And what we're actively doing, first that I know of, actively doing this with multiple manufacturers' cars out there, is we are able to communicate with the car, and we're able to use that car battery and use that function of charging the car as a frequency mechanism in the German market. So we actually can make money by regulating the way we charge an electric vehicle, and do that in such a way that it benefits the German grid and monetizes. Where I believe that's going to evolve, again, I totally agree with you, where I believe that's going to evolve eventually, is that when car manufacturers really do get comfortable with the technology of their battery modules, the rate of discharge and the rate of charge, and how they can allow those movements of energy back and forth, I think you do see a true vehicle to grid scenario where a car could be more of an asset. I think the question that we all ask, as a society is, does that landscape look like car plus a stationary battery? Because one of the scenarios that I run into a lot as an electric car owner myself is, am I comfortable not knowing the state of charge of my car? Like, if I was to lend my car to a grid event in California and they drain my car down because it made me $50, what happens if I need to go then get in my car to go do something? I mean, God forbid it's an emergency. I got to go to the hospital or something, and my car has been substantially drained. Would I want some type of flexibility to say, I have an electric car, I'm willing to lend some of that, but I also have the stationary battery that's really purpose-built, purpose-installed, purpose-integrated into that ecosystem to be able to do that 24/7, 365. And then I've got my electric vehicle that's a backup for that I could use in emergencies, but is also available to me if I need to go run errands, or I work a weird swing shift and I need my car to be available at 8 o'clock in the evening so I can go to work. So I think there's a lot of really cool different use cases out there where the electrified system of the future is a combination of a lot of electric cars, bi-directional charging, intelligent bi-directional charging or discharging of vehicles, as well as stationary energy storage systems that are purpose-built and installed for those purposes as well.
Yeah, the one way that I kind of see it, with the bi-directional electric vehicle is probably you'll be like have an app or something like that and say, oh, I'm going to leave tomorrow morning at this time. I need my battery at 80%, no matter what. And so that's going to be guaranteed to happen. And a lot of times too, like you mentioned the frequency regulation. And so just for the people out there that don't know what frequency regulation is, a lot of times people think of energy storage as like you put it into the battery and then it's like hours worth of energy and then you take it out later. And so you're cycling your battery up and down. And so we might call that time shifting or something like that. And that's pretty common. But frequency regulation is just if the grid slows down, you inject power into it. And if it speeds up, you take power out of it. And that's something that can be done with a very small percentage of the battery. Sometimes it's just like one sine wave to the next. Yep. And I know that that's for the big power plants. I'm not sure exactly, if they can control it at this point in time with virtual power plants. And so that also leads to some of the things I was going to ask you about, like, too, what are the different types of, call them like ancillary services that you can offer? Would it be the same as with the big power plants? Maybe it would even be better because it's distributed all over the place. So we have like frequency regulation. There's something else called reactive power, which is taking like current and voltage and throwing them, offsetting them from each other so they peak at different times. And reactive power supports the voltage when you're transmitting electricity over long distances. And there's a whole bunch of different things that you can do with that, and I think have to do with the grid of the future.
Yeah, I know you're absolutely right. So I think it goes to your earlier comments, an individual 20 kilowatt hour battery with a 4, 5, 6, 8 kW inverter in Susie Smith's garage. That's like throwing a pebble at a freight train.
But if you have a million pebbles, that'll knock it off the tracks.
That's exactly right. And that is, from my perspective, from my personal perspective, that is what a virtual power plant is. That is virtually controlling tens of thousands, millions of assets that can provide both grid decongestion, load offset, solar time shifting, which you alluded to, grid load shift, which is kind of an evolution of solar time shifting. And when you can swarm control those things and you have highly reactive, fast reacting, durable inverters that are highly dependable, through that software layer, then yes, you can offer everything that a traditional power plant does. And I'll call it out specifically with Rocky Mountain Power. One of the primary mechanisms that they love to use the WattSmart cluster for is for frequency regulation. Frequency issues happen completely randomly for every reason under the sun that you could think of. What I would say is a frequency event happens on the Rocky Mountain Power grid several times a week, steadily. They're little things. It's not like, oh my gosh, the grid's about to go down, so please don't think their grid is unstable. This happens everywhere. There are frequencies all over the place. And the primary tool that Rocky Mountain Power now uses is the WattSmart cluster batteries. We provide almost 14 megawatts of instantly dispatchable power to help lift the frequency when it droops a little bit, using batteries in people's garages and in businesses around the Utah, Idaho, and Wyoming areas.
And like, how quickly can you react to that? I'm assuming it's over the internet. They have to signal it what to do through Ethernet or something like that. Yeah. And then is it it's milliseconds, right?
Yeah, I guess I would say maybe for purposes of the podcast, it's seconds. There is full power reaction from almost 3,000 individual inverters within seconds. And what I would say is, in terms of standards on the grid, a spinning reserve, one of the standards for spinning reserves is that it needs to react within 30 seconds. So we far exceed some of the grid standards that are used for traditional fossil fuel-based power plants to provide the exact same service.
Yeah, and another thing that they call that too is synthetic inertia. So you have the spinning reserves, and that's the inertia of something spinning. So you have coal plants, people are making things really hot with nuclear and coal and stuff like that, and they're spinning it. And those things, they have a lot of inertia, so we make synthetic inertia with our electronic inverters and with our batteries, and which is pretty cool. And then for frequency regulation on the grid, a lot of times what they're using is essentially a jet engine. They have, like natural gas, they call it, however natural that might be. And it takes a while to crank those things up.
Yeah, absolutely. Those are your traditional peaking power resources, which is really sad to say because, in the last 10 years, we've probably added, nationwide, we probably added more peaking resources to our grid than anything else. It far exceeds new baseload generation being built to deal with that daily cycle. California sees it really badly. I just moved recently from Arizona. We saw it really badly in Arizona. Obviously, Hawaii has some major things that they're dealing with. And we saw this in Germany. And again, this is where the virtual power plant really was birthed, on the planet, is from the German region, where they went from this paradigm of highly incentivizing renewable energy, specifically solar, to saying, whoa, that worked really well. We've got a lot of solar on the grid, so much so that it's actually starting to destabilize the grid. We're seeing instances where we're having to add natural gas, fossil fuel-based peaking resources to deal with this thing because, hey, I don't know if anybody realized, but the sun goes down every day. And when the sun goes down, this beautiful resource of all this renewable generated energy goes away. Coincidentally, everyone's coming home from work, coming home from school, cooking dinner, taking showers, doing laundry, and we've got this massive swing from massive overproduction to massive demand. The only way you could react to that quick enough were with those simple cycle, jet engine, essentially, power plants that you had to spin up 30 minutes ahead of the curve. Highly inefficient, highly, one of the most CO2 intensive power plant resources. And we can shift that, with millions of inverter-based grid technologies. I wrote that down. I love that. Whoever you contributed that, you make sure we get that in the show notes.
His name was Peter Green from InRealm.
Peter Green. Thank you, Peter.
Gave a talk last night.
Great term, Peter.
Yeah, so one way of looking at it too might be like if you're sitting on a jet plane and it's just idling, and then you're ready to ramp it up, but you just kind of have to leave it idling, and that would be, just sitting there on standby too, wasting quite a bit of kerosene, which is also known as jet fuel. Smells really good.
Well, as a pilot, I do love that smell, but it's certainly not great for the environment when you really drill down to it. So
I noticed you were using what did they call it? The phonetic alphabet. So I have a private pilot's license myself. So
right, exactly. Yeah, that's perfect. That's awesome.
Sierra, Bravo, Papa, and all that kind of stuff. So great. And so let's see. So we've been talking a little bit about, kind of like software and all the kind of neat stuff that it can do. And so maybe we can talk a little bit more about the hardware. Are you still using Outback hardware inside of your equipment?
Yeah, Yeah, some of our equipment is still Outback inverter based, phenomenal product, one of the most robust inverters out there. Our newest generation of equipment is now using a homegrown, invented, patented technology. We call it the Sonnen inverter. So it is now our inverter that we manufacture ourselves and put in our units. That's being used here in the US as well as Australia right now.
How long ago did that happen when you switched from Outback?
We started transitioning, I'd probably say maybe about 2 years ago. Both are still in use, and then there's a couple of other inverters that we use over in the European Union still.
Yeah, I know Outback does have a great reputation, especially amongst people, living off grid. They've been around for longer than probably most any other inverter company. So I remember I was trying to get a job out in Antarctica, and they were using Outback inverters there. That was quite a while ago. I still like to get that job, but I just can't take 5 months off. That's the problem.
I don't know that I can take the cold. Yeah,
well, it's just like going to Mars, and so prepare me for my Mars trip.
There you go. That's on my bucket list as well.
So some heavy duty inverters that you have there too. And another thing too is like there's all this, manufacturing going on with the Inflation Reduction Act and all that kind of stuff. Are you guys looking at that right now?
Oh, certainly. Yeah, I think there's always a heavy focus. I'll speak for what I know of Sonnen specific. There has always been a heavy focus at Sonnen around seeking out the best technologies, whether that's cell technology, module technology, inverter, and manufacturing techniques to bring the best technology we can to market at the most cost optimal price. So yeah, we're always looking at where can we source certain things from, specifically around the US manufacturing. All of the steel, so all of our wall bracketry, shelf brackets, the casing around it, that's all sourced here in the US. And then we do some creative global things around bringing in inverters from our manufacturing sites and modules, of course. So yeah, there's a big focus on that, always looking for better ways to do it, to stay relevant in the market and to harness all the amazing mechanisms that, in this case, the U.S. government makes available to us to aid and speed the adoption of renewable energy storage systems specifically.
Great. And so another question I have is a couple of things. One of them is about the installers, like how does somebody, install Sonnen batteries? Do you just buy it from a distributor? Are there special Sonnen distributors? I know there's like a certified installer program. Mm-hmm. And then as far as just getting somebody to install it on their own wall, I saw that you can go on to the Sonnen website and just enter your name and your email address. I guess what you'll do is connect somebody with an installer. So how do we get more Sonnen batteries out there?
Great question. I love where you're going. Yeah, 100%. So our website's a great resource, sonnenusa.com. If you click the Find an Installer link, it will help us connect you with a local installer that has been Sonnen certified. So we do certify installers to know our product lineup, know the product families, know how to come to your home, give you a professional bid, if for solar, very important, as well as for Sonnen energy storage systems as a whole package, so that we can ensure that it's a great experience. We want to make sure that it's bid well, that it's sourced well from distribution, that it's installed well, safely, effectively, efficiently, and then connected into the grid and the internet so that it can be used for really what it's meant to be used for, not just as backup, but for whatever that local market may enable for that individual homeowner. We really want to make sure that battery is used 24/7, 365 as much as possible, because that's really how we affect energy transition and embrace renewable energy moving forward.
Yeah, I know in Germany that the grid got a reputation for being so stable that a lot of people don't even wire their systems for backup. It'd be a couple thousand extra euro or a couple thousand extra dollars to wire the house for backup. And so they just use it for what we call self-consumption. And that means, when the sun's out and you're not home, you fill up the battery. And then as you come home and you start using more than you're making, then you start using that electricity from the battery. And so do you see that in the United States? Is everybody doing backup because we're a bunch of preppers over here, kind of more paranoid? No, just joking. How do you see that? Or do you have kind of a feel for how many people are using it with backup and without?
Yeah, great question. Yeah, again, I think that's evolving. I would say even as early as like maybe a year ago, the vast majority of the US market was backup number one. I'm buying a battery for backup number one. I'm shopping around looking at what that would cost because I realized that it doesn't have an ROI. If you're buying a battery for backup, there's no ROI. It's peace of mind. Your ROI is safety, security, peace of mind. And if an installer, goes out, door knocks, or comes out to a home because we sent them a lead, if they can demonstrate that this battery could do more, that it could do self-consumption, as you alluded to, or if you're in a part of a country where you've got really aggressive time of use rate plans where you can harness time of use, store solar, and avoid paying those peak and partial peak periods, there's a really cool value proposition around that battery doing more. And I think what you're seeing, if I'll be bold for a moment, what I think you're seeing in the marketplace is a lot of manufacturers realizing that if they want to be part of that landscape, that they have to change their hardware technology. 10 years ago, when Sonnen was coming to the US, people flat out called us crazy for using lithium iron phosphate as our battery technology. Like, that's nuts. It's expensive. It's heavy. The energy density is lower. Why would you do that? It makes no sense. You're never going to be cost competitive. And now today, what you see is by and large, just about every major player is either shifting to or adopting or offering lithium iron phosphate as a battery chemistry for their systems because it is so safe, it is so durable, it is so robust. Because if you are going to beat the snot out of a battery every day and say, I'm going to drain you down, I'm going to fill you up, I'm going to drain you down, I'm going to fill you up, we're going to do self-consumption, we're going to do time of use. Hey, if you're part of a VPP, we might ask you to do frequency regulation or some other crazy thing. That chemistry really needs to be there to support that type of use case and to be competitive in a landscape where we might be shifting away from backup being, the leading value proposition. And I'll say this, one of the early adopters of this, not toot my own horn, but I'm kind of proud of it because I think we saw it coming. When we were installing solar and battery in Mandalay homes in northern and central Arizona, we did not wire them for backup. APS, Arizona Public Service, has a very stable grid. They're a fantastic utility. And we just didn't see the need to necessarily provide backup to our homeowners, provide a PLP to homeowners as a default function. We optioned it. And I will tell you, of the thousands of homes that we sold while I was at Mandalay Homes, that option was bought 0 times.
Wow. Okay, that's really interesting. So 0 people in Arizona, of all places, where I'd expect there to be a ton of preppers, are not doing backup. So,
yep. Interesting paradigm. I did not expect a 0% uptake either, but it was important to us because, backup does burden the ticket price a little bit. It can,
Sure.
A PLP costs money, breakers cost money, wire costs money. So if you don't need it, or if it's not important to that consumer, why not remove that from the sales proposition and save them a couple $1,000s?
Wow, that's crazy in Arizona too, because I was just visiting my daughter who lives in Arizona, and she was a little concerned of, what's going to happen in the future, climate change, and people are going to die without air conditioners and things like that. And then they're not, of all the places not to get backup. That's very interesting. You were also talking about LFP, lithium iron phosphate. That's a type of lithium ion battery. And the other big thing about that too is, it takes up a tiny bit more space. It's a tiny bit heavier, but we're not putting it in a car in this case. Right. And it does have a good application even for cars. My girlfriend got a Model 3 Tesla that has lithium iron phosphate in it. It's in cars and stuff too. But the lithium iron phosphate does not require cobalt. And cobalt is sort of a conflict mineral. They're mining it from the Congo, and a lot of people, they say that they're using child labor and stuff there, and it's just kind of hard to get. Half of the cobalt in the world is coming out of the Democratic Republic of Congo, and it's just not a very stable place, and hopefully we can fix some of the social problems affiliated with cobalt too.
I couldn't agree more. Yeah, I'm personally very proud that Sonnen has been cobalt-free since its inception in 2010. Just a non-starter for us, both for the social reasons as well as some of the recyclability features of it.
Yeah, and as lithium ion technologies get better, eventually, lithium iron phosphate is going to catch up with the specific energy and the energy density of the cobalt-based batteries of, however many years ago. Just technology gets better and better, and people get more and more comfortable with it. And especially if you're putting it on your house, it's not like you have to accelerate your house or anything like that.
That's absolutely right. Yeah. And then when we start winning the battle with the National Fire Code, the International Building Code, to really start to draw out the differences in battery chemistries and what their relative risk level is in a stationary energy storage system, no different than a vehicle, then I think you'll really see some changes in the U.S. built environment.
Yeah, I would imagine that Sonnen is working with the International Residential Code, the IRC.
IRC, yep. IBC as well, because we're in that commercial space, and then definitely the National Fire Code.
Great. And speaking of that commercial space, I know you're kind of famous for the residential space. So how is it with commercial, or like what percentage of your energy is going to residential versus commercial? And then are you doing bigger than commercial or eventually sometime, or what's that looking like?
Yeah, great question again. Yes, Sonnen was founded as a residential energy storage system. So I would say today it's a ginormous part of our portfolio. We launched a commercial battery here in the US about 3 years ago with some partners in Utah. We've got some installations in Utah, Arizona, California with that system. It's called the EcoLinks 100. It's a 3-phase 30 kW inverter and 100 kWh of energy storage. Again, lithium iron phosphate, except no substitute. And we could stack though. The other thing that was really cool about that was our first offering that we could electrically stack systems. And we've got some really cool installations, a lot of really cool use cases. The clubhouse at Soleil Lofts, for example. So every unit has a residential unit in it. And then they have this big, beautiful clubhouse that has pools and their gym and all the amenities you expect from a really nice apartment living community. And they wanted to continue that message of pure electrification, renewable energy-based energy storage harnessed and utilized in harmony with the grid. So we have our commercial batteries in that clubhouse, a couple office buildings. We have batteries in some commercial hangars where they're doing some mixed use with airplane hangars. So yeah, I mean, the use cases are pretty endless. I think you will see gas stations, for example, as they begin to embrace EV charging, level 2 and certainly level 3 EV charging. I think you'll see batteries start to kind of infiltrate the commercial space there, where they're looking to be part of that fueling landscape and need solutions to not having to do really expensive grid upgrades so that they can support a couple of fast chargers. But yeah, it's a really interesting space. We love the commercial space. At Smarter E in Munich back in June, the German company introduced a new product that will be launching in Germany in January called the Flex Stack. So that's the commercial offering that we'll have in Germany in the short run. And then we'll continue to do really cool projects with EcoLinks 100 here in the US.
Yeah, great. I love that conference over there in Munich, and it used to be called InterSolar, but everybody's taken solar out of their name of their conference, just like we have RE Plus instead of SPI, which people are having trouble converting the language to. And I'm
good. It's not just me.
I'm on a jury to give out awards also for that conference, and so it's pretty neat. I have some pretty good friends over there in Germany. So you and I are both, based out of California, I guess. I think you said you're in San Diego, and
yes,
I'm in the Bay Area. And one of the things that we had in the last year that was kind of crazy, they call it NEM3, and so it's like changing the net metering so you get less money when you export. And I imagine for your company, that's probably a good thing. And so a lot of the solar installers were saying, hey, it's the end of the world, and they're taking away our ability to export, and they're going to give us something like a third of the price for the energy when you export instead of 100%. And so that just gets people to get batteries. I know in Hawaii, they pretty much don't even let anybody export at all. It's like zero export. And I think that's where probably Sonnen got a big head start in using batteries in the United States. And now with this net metering 3 that's going on, are you seeing a lot more battery sales in California, or perhaps it hasn't started yet because everybody got their reservation in and they're still installing those systems under net metering 2?
That's awesome. You are well connected, sir. Yeah, exactly. We are absolutely seeing an uptick in requests for information and in potential partnerships to provide solar plus battery under NEM 3. So net metering is gone in California for all intents and purposes. It is now a net billing tariff, NBT, where energy exported to the grid from any source, wind, solar, whatever it may be behind the meter, is credited at what it costs the grid operators to generate a kilowatt hour from other sources. And this is nothing new. I think it's interesting that we were shocked as an industry that this was coming. This certainly has played out in Europe. It's played out in Japan. It's played out in Australia. So we've seen this movie before. When you reach a certain penetration level of renewable energy, you have to transition. And again, if you're serious as a society about actual energy transition and saying, we'd like to move away from fossil fuel-based generation in the future and embrace more of this natural stuff going on. The sun's going to continue to shine, so why not harness that? You need to look at business models that make sense. Net billing 1, way back in the day, or what the vast majority of the country still has, consumers are paid a 1-for-1 credit for every kilowatt hour that they export to the grid. So you push one out to the grid, the utility gives it back to you. And I don't know of any other business model on the planet where you can buy something for $1, sell something for $1, and somehow expect to stay in business. So if we're serious about energy transition, NIM 3 was a natural progression, and it had to happen. And it was important that it happened because it allows us as Californians to continue to be on the leading edge of renewable technology in a really well-informed way, where we're embracing renewable technology and recognize that the sun comes up and the sun goes down every day, yet our energy habits demand that we need electricity 24/7. So how do we do that? Yeah. And I think NIM 3 really kind of is the financial mechanism that enables that.
Yeah, and back when we had net metering 1, which I'm happy to be grandfathered into, we said the grid is a perfect battery. You can send a kilowatt hour there in the middle of the summer and then use it in the winter. And of course, that's an incentive to get people to go solar, but as more and more people go solar and the price of solar goes down something like tenfold over a certain amount of time, you just can't afford to do that, and then the grid just won't work, because there's got to be some place to send it. When solar was just a fraction of a percent of the grid, that would work. So I believe it is a natural progression of things. The one thing that I have on my wish list, though, for all these people that are making up these rules, is to make things happen a little bit more gradually. So it's not just this all of a sudden, all at once thing. One of the things that the California Solar Initiative did is it was a gradual step down. So It wasn't like an end of the world thing. And I remember too, when not too long ago, when the investment tax credit was fading out, and it was just going to make this huge jump down, and it makes it really difficult for people to do business and people to make investments years ahead of time, which is required. And it makes people lose their jobs because people are just going to say, I have to do a bunch of layoffs because I can't be guaranteed that this is going to be the same financial incentive that we're going to have in the future. So, it's like, I know that eventually we're going to see net metering go away everywhere because we're going to be 100% renewable. I believe that's just something that's going to happen. And so I just wish that we could make things happen a little bit more gradually, a little bit more in steps instead of cliffs.
Yeah, I would totally agree with you. If you inadvertently destroy an industry in the process, you're working very counter your goal, because if nobody wants to be a solar contractor anymore, and nobody can afford to be a solar contractor anymore, or to have the skilled labor on their crews to climb on these roofs to do this really important, skilled, difficult work, then you drop off a cliff, and what you're aiming to solve becomes unsolvable because you have nobody to implement it. So I would totally agree with you in the way we approach it.
Great. Okay, Geoff, is there anything else that you want to talk about or that we didn't cover?
No, it was a great discussion. Thanks, Sean. I really appreciated it. Really interesting questions. I love where you were leading your listeners, and hopefully we're able to provide some insights that are valuable to folks out there. And if they need any other solutions to their projects, multifamily, commercial, if you're a utility looking for solutions to help you embrace customer generation, behind the meter load, behind the meter generation, feel free to reach out. We'd love to talk to you about your projects and show you what Sonnen products, both hardware and in homes and businesses, as well as our VPP software layers, can do to help you with your goals.
Great. And do you want to tell people where they can find you or find out more about Sonnen, how to spell Sonnen one last time so they can look it up?
Absolutely. Yeah. SonnenUSA.com, SONNENUSA.com. Fantastic website. My name is Geoff Ferrell. You'll see it in the show notes. It's spelled funny, so Sean will get it in for you. I'm certainly on, how many? Threads, LinkedIn, Twitter. You can reach out to me, Geoff. It's G.Ferrell, Ferrell, at zonen-battery.com. If we can get that in the show notes as well, because battery spelled funny, because why not?
For sure. All right. Yeah, that's Geoff with a G, Geoff Ferrell. Thanks a lot. Yeah, I enjoyed talking to you. So, I guess you probably go to the conferences and stuff too, right?
Yeah, in addition to the platforms where you can reach me or reach out to Sonnen directly through our website, we will be at RE Plus this year. So really looking forward to that conference in Vegas. You'll find us on the show floor map, and we'd love to meet with you.
Thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more about solar storage and everything else under the sun, go to Solar, SEAN, that's SolarSean.com, and get yourself educated.